Hey Calc, this is section 6.4. I'm only going to go through about half of it, or probably just like 3/4 of the first page. So hopefully this is a short video for you. But in section 6.3 we kind of talked about like definite integrals and how they're set up. So I think the example that I used was like -2 to 1 of 2x dx, and talked about how the graph of that would be, a function that looks something like this, and we're going from -2 to 1. So basically we're looking at the area at these two areas here, okay, and adding those together. So this is a negative area, that's a positive area, putting those two together. Now, we're not going to be drawing anything, although I probably will draw some of these for you just so you can kind of see what it is that we are doing. But we no longer have to draw anything. We no longer have to do any rectangles or any estimation or anything like that. All we do is evaluate the definite integral, and that will give us the exact area. So finding the antiderivative, evaluating it, will give us exact area. Okay, and so here is the clue. This is what we do in this section. This is called the fundamental theorem of calculus, which makes it sound really daunting, but it's actually like super easy. When you find the antiderivative of some function, it looks like this, f of x, okay? Then all you do is, with that f of x, you will plug the upper limit in and subtract what you get when you plug the lower limit in. And that will give you your exact area of like these two together, okay? So I would find the antiderivative of 2x, whatever that may be. I would plug in 1, okay, subtract what I get when I plugged in -2, and that would give me my exact area for this function here, okay? So they're going to have us practice this for example 1. They're saying x to the third power, okay? So I'm going to kind of draw this just so we can get an idea of what we're doing here. X to the third power is going to be something that looks like this, okay? And they're wanting us to go just from 1 to 3. So basically I'm kind of sectioning them off at 1 here and at 3 here, and I'm trying to find this area underneath of that curve from 1 to 3, okay? So what I do is I find the antiderivative of x to the third, okay? And so if you need to write the formula out, you sure can. 1 over n plus 1, x to the n plus 1 power, and that will give us that, and we have to figure out his antiderivative. So my n in this case will be 3, so this will be 1 over n plus 1, or 1/4 x to the 4th power. Okay, that's what his antiderivative will be. Okay, always kind of mentally check in your head if it's an easy one. If I take the derivative of this, then do I get x to the third? I would multiply the 4 down in front. Yep, that would cancel the 1/4 out, and it would be x to the third power. Okay, now the notation that they will use after you have taken the antiderivative before you plug your numbers in is they'll do a little line here, or like up here they did a bracket. And what I will do is I'll write my numbers at the end, okay? And basically what writing it in this way says, I've taken the antiderivative is done, but I haven't plugged numbers in. So need to sub numbers, okay? That's basically what it says up to this point, okay? So I write out my antiderivative, and then I put a line at the end, and that kind of helps me track where my thought process is at, okay? So from here, I'm just going to plug 3 in, so 1/4 times 3 to the 4th power, and subtract what I get when I do 1/4 times 1 to the 4th power. I'm going to run out of room here. So 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. So this is like 81 over 4, minus 1 to the 4th power is just 1. So that would be 1/4. Okay? And 81 over 4 minus 1 over 4 is going to be 80 over 4, which is 20. So this guy right here, from 1 to 3, will have an area of 20 underneath of that curve. Okay? And I found the exact area. There's nothing else there is to it. Okay. Example 2, just another problem like this. We can do 3 square roots of x, and we need to figure out what his antiderivative is. So we'll do that first. I'm going to go all the way up here at the top. I'm going to write this as 3x to the 1/2 power. okay? So again, we have 1 over n plus 1, x to the n plus 1, okay? And in this case, since there's a 3 there, I'm going to put the 3 on the top. So it would be like 3 times 1 on the top. My n is going to be 1/2, so this will be 1/2 plus 1, x to the 1/2 plus 1. Okay, that's how his antiderivative is going to look, okay? And then let's go ahead and solve him. So 1/2 plus 1. Okay, think about what that would be as a fraction. 1/2 plus 1 is going to be 3/2. And then if I keep flip him to the top, this is 3 times 2/3 is what it would be. Okay, what is 2/3 of 3, or 3 times 2/3? That's just going to be 2x to the 3/2 power. Okay, so now at this point I've taken my antiderivative, I'm done with that part, and so I'm going to write him with a little line at the back going from 1 to 4, so I can just kind of track my steps. I've taken the antiderivative, but I haven't plugged my numbers in yet. That's what I'm going to do now. And plugging 4 in first. So 4 to the 3/2 power minus 2 times 1 to the 3/2 power. Okay, now the 3/2 power might help you to think of it this way. 4 to the 3/2 power would be like the square root of 4 and then cubed, right? This is the second power goes, or the second root goes in there. So the square root of 4 is going to be 2. 2 to the 3rd power is 8. So this guy is going to be 8 right here. 4 to the 3/2 power is actually 8. So 2 times 8 is going to give me 16. And then 1 to the 3/2 power would be like the square root of 1 cubed. The square root of 1 is just 1. 1 cubed is 1. And so 2 times 1 is just going to be 2. And this guy is going to have an area of 14. So 3 square roots of x, if I'm looking at that curve, think about the square root of x is, you know, one of these guys, okay? And we're going from 1 to 4. So I'm finding this area underneath of there is 14. And that's his exact area. We don't have to use triangles anymore. We don't have to use anything like that. Very easy process, okay? All right, last one. 2x minus 1. Oh, this one's going to be a little bit trickier. I might do this on a separate sheet of paper. Sorry, I didn't give you very much room to write. You probably have room if you want to write it down here in this space, because we're probably not going to use that space. But I am going to write this on a separate sheet of paper just so I know I have enough room. Okay, so because we have absolute value, this makes it kind of ugly. 2x minus 1 inside of an absolute value, what he will look like is 2x minus 1 is going to be to the right, and he's going to touch at 1/2. Okay, like think about if I take 2x minus 1 and set him equal to 0. Ooh, we're really fuzzy. I would add the 1 over, and 2x would be equal to 1, so x would be equal to 1/2. So he's touching here at 1/2, and then he's basically doing one of these, right? He's doing a v aside from that. Okay, we're wanting to go from 0, which is here, to 2, which is somewhere over here, and I want to find this area. Okay, so that's what he's going to look like. All right, now this is one of the cases like we had in the last section where it's going to be easier to section him off into 2 separate integrals that you add together. Okay, the first one is going to be this left side one over here. Okay, and because that left side is going downhill, he's like the negative of the absolute value. Let me get this unfuzzy here for you. Okay, what he's going to look like is he's going to be the integral from 0, starting at 0, going to 1/2 of negative 2x minus 1. Okay, and then we're going to do the integral from 1/2 to 2 of the positive 2x minus 1 dx, because he's going up here. I should have a dx on there too, because he's going uphill. Okay, so kind of just take a second to absorb that and think about what that means. Going from 0 to 1/2, he's going downhill, and from 1/2 to 2, the remainder of my integral, he's doing the positive 2x minus 1. Okay, so then we just have to do each piece separately and add them together, and then we are just done. Okay, so from 0 to 1/2, let's do negative 2x minus 1 is like really negative 2x plus 1, and we need to do his antiderivative of negative 2x plus 1. Okay, So antiderivative of negative 2x plus 1, negative 2x would be like negative 2 over n plus 1, which is going to be 1 plus 1, x to the 1 plus 1 power. Okay, this will be negative 2 over 2, so really negative 1x squared is the antiderivative of negative 2x. Okay, think about this guy. If I take the derivative of him, really fuzzy, come on, zoom. Okay, if I take the derivative of him now and I bring that 2 down in front, that will give me negative 2x. Okay, now we still need to do the 1, so the 1 down here. What would the original have to be in order for the derivative to be 1? And that would be just like 1x. Okay, now here's where it's really important to use this little line to track your thoughts, because we have a whole bunch of stuff going on at the same time right now. Okay, so this means I've taken the antiderivative, but I haven't plugged my numbers in yet. Okay, so let's just continue this piece on rather than doing 2 of them at the same time. We'll just get a final answer here, get a final answer over here, and add them together. So we want to first plug in the 1/2. So negative 1 times 1/2 squared plus 1 times 1/2. And I want to subtract what I get when I plug 0 in. So negative 1 times 0 squared plus 1 times 0. Okay, I'm just doing those 2 pieces. Okay, this is a lot of steps, but the steps aren't terribly hard. So as soon as you get through the steps, it's pretty well easy. Okay, 1/2 squared is going to be 1/4, and I have negative 1 times 1/4. So I've got negative 1/4 plus 1 times 1/2 is right here. 1 times 1/2 is just 1/2. Ugh. And then minus negative 1 times 0 squared plus 1 times 0. This whole thing is going to end up being 0. So that's kind of nice. All right, then I just have negative 1/4 plus 1/2, which is just going to be a positive 1/4. Okay, that's what his area is. All right, so that, again, that 1/4 is just going to be the area right here. Okay, just this little area right there. That's a 1/4 of a unit. Okay, then let's go ahead. So that was this piece right here. Let's go ahead and do 2x minus 1. So the first thing that we want to do for our 2x minus 1 is we want to take his antiderivative, which is going to look really similar to the antiderivative that we got here, except this one's going to be the positive of that. Okay, so 2x, if I do 1 over n plus 1, x to the n plus 1, really it's going to be 2 over n plus 1, 2 over 1 plus 1, x to the 1 plus 1, or this would be 2 over 2, which is 1x squared. So 1x squared, the derivative of him is 2x, right? And you might have been able to do that in your head, and that's fine. So x squared is the antiderivative of 2x, okay? And then negative 1, he's going to come down here and think what would the original have to be in order for the derivative to be negative 1? It would have to be negative 1x. The derivative of negative 1x is negative 1, so we have this guy. And now I'm going to write out, and I'm plugging in 1/2 to 2 is the section that we're doing there. Okay, so I'm going to start by plugging in 2 first. 1 times 2 squared minus 1 times 2. Okay, that's that first part, minus 1 times 1/2 squared minus 1 times 1/2. Okay. All right, so 1 times 2 squared is going to be 4. 4 minus 2 is just 2, minus, okay, this guy is going to be 1/2 squared, which is 1/4, minus 1/2. Okay, 1/4 minus 1/2 is going to be a negative 1/4. Holy cow, that's really gross. 1/2 or 1/4 minus 1/2, yes, negative 1/4. So I have 2 minus a negative 1/4, which is 2 plus 1/4, or 2 and 1/4 as the area of the second piece. Now I just want to add those two together. Okay, and that will be 2.5 square units as my area. Okay, that was a superly ugly antiderivative problem. I probably won't expect you to do one of those by yourself. It'll be more along the lines of the first two examples that we did. But as long as you followed along with that and kind of got through that, with me as I went, that's huge. If you were able to follow through and kind of make sense of that, 2.5 units squared. Okay, so again, that's kind of a hard problem. This area right here, if you add those two sections together, will be 2.5 square units. Okay. All right, and then let's see. That might be where I want to stop. We'll stop there. We'll go over this note in the next video, and then we'll do the mean value theorem and the average value theorem on the back side. Okay, so be looking for that in the next video. That is all I have for you here. I will post some problems inside of this video. Please comment and give me feedback if you like this method, if you don't like this method, if you want me to keep doing the homework this way versus you actually writing stuff out. Maybe just comment below in this assignment, so I just kind of know which one you prefer. Okay. All right. That is all I have.